where they extrude something, and then like a thing closes on it, and then you got this little needle that blows air in it, and so the kind of inner layer kind of goes out, and then it takes the shape of the outer kind of die that you put around it. And these kind of things, and it's fascinating, it's interesting, and it's very important for you to also understand. So that's production materials done, maths done, mechanics done. The other one, computing. Oh my goodness, computing. I got a D from computing. Everything else, I think I got an A, perhaps mechanics I got. Anyways, doesn't matter. Computing I got D because I did not practice enough. Okay, you need to practice with computing, and you also want to. So the difference with computing to everything else is with computing you're actually allowed to look up things during the exam. So you're allowed to look onto Google and whatnot. So I think my tip for computing is get used to doing that, like constantly. You run into an error, immediately just search it up. Because you have this kind of initial disposition to think that that's cheating. It's not. That's what you're meant to do. In computing, no one becomes a pro. When you're coding and stuff, it's not, you don't ever totally master. Even the lecturer said to us, who's computer scientist or whatever for a long time, even he said that, even he hasn't mastered coding. Like, you always need help. You always need to look up things. So that would be my tip. I couldn't do that in the exam. I didn't do that in the exam because I felt for some reason like I was cheating or something. So yeah, I got a D. Anyways, that was computing. So that's 4. What else did I say? I think there was 5, wasn't there? What else? Electronics. Oh my goodness, electronics. Electronics was quite intense again. It's very intense actually, because there was we would go into these the electronics department, really. We'd go there and we would be given like a task, we'd be given like a sheet of things that we had to accomplish in that thing. And they would have it'd be quite wordy. There'd be a lot of things that you'd have to do. And so the idea is they're trying to get you used to kind of learning. So these were the labs, by the way. So there's lectures, but also labs. But again, I just want to say that it was very, very useful. Like, they were very useful in many ways, but they really push you in a way as well, to kind of get used to the different components that you can use in electronics. So there's capacitors, you've got transistors, you've got the resistors, you've got diodes, you've got LEDs, obviously, you've got motors. So in electronics was kind of also combined with Python coding. So we were given a task where we would have to control motors from sensory feedback that was given from IR sensors or ultrasonic sensors and stuff like that. So it's quite, it was. You can imagine the uses of electronics in something like design engineering, I mean, designing products and stuff. It was very useful, I'd say, but also very challenging. I would say take your time with it. Usually the tutorials where we are meant to kind of do all the tasks on a worksheet are quite fast-paced. I'd say don't be afraid to come in afterwards and complete the task if you can't complete them within that tutorial. In fact, I would highly, highly recommend you do that. I know it's very hard to find the time to do stuff like that when you're at Imperial, but I would do that. I kind of regret not doing that because I felt like I was quite behind with electronics. I couldn't really help with the group project at the end either, but I did, but usually with the physical side as opposed to the electronic side. So it's something that I'm trying to catch up with. In fact, another great tip would be to buy your own personal Arduino kits where you have a breadboard, you've got cables, you've got your Arduino, and you've got different kinds of sensors and things that you can add to the kit. I would highly recommend you buy something like that beforehand, and so that you're constantly playing with it and you're constantly kind of improving your ability to kind of connect things and think, or like have a better understanding of what each component actually does in electronics. Another thing about electronics is really weird because, like, you can't see it. When a problem occurs, you don't know where the problem is, and don't get lost in the tiny details. So our lecturer Peter Chung would always say that. He'd say there's 2 areas you can go. One is you go really fine details, like where are the electrons going and blah blah blah, so you get lost in the really tiny details, or the other is you just think really large and you just get overwhelmed. So so it requires a different kind of thinking, electronics, and it's really good, again, to be able to kind of develop that type of thinking, as that type of thinking actually applies to many areas, I think, in design engineering as well. Cool, so that's for electronics. Right, I think that's about all 5, right? Now for the more creative, expressive, perhaps, design modules, right? Obviously, the first one, design. Design 1, we had... Design 1 was, again, intense. but is also again very, very useful, probably one of the most closest things to what a design engineer would be doing. It kind of combined a lot of different areas, but there was a particular focus, obviously, on, meeting human needs. What's the design process when you are designing? We had a module called functional products, I think. Another one was meaningful designs, where you actually make design that's meaningful for people, what makes it meaningful for people. You learn about personas, so making personas where you make like a personal, who you're designing for. You kind of construct a person, just an imaginary person. You write about them, it's your own character, and you're saying, I'm designing for this person, depending on the market that I want to sell to. This person is representing kind of them kind of thing. So that's just one example. But they also teach you about the different design methods. So you've got empathy. Like you create an empathy map. You got the immersion. Sorry, that's what I meant. Yeah, immersion. That's a design tool where you actually go into the situation where that particular design that you're designing would be needed or be used. So yeah, again, you just have, like, they're just equipping you with a ton of skills, a ton of tools to be able to meet the human needs when that you're trying to design for. That was design one. Flip neck. I think design one lectures were some of the lectures that I most enjoyed, because the pace of the lectures were, I think, really well, and they were also not too technical to the point that you could just understand it in the lecture. You wouldn't have to think afterwards and go through things, which I rarely ever did with any of the lectures, really, which I regret as well. I think I would highly recommend you guys to do that because of the intensity of lectures, to re-watch lectures, pause when you want to pause. I think to be able to do that, have that technology, that opportunity is a very is a great advantage, and use it. Yeah, so that was design one. The other one about design and communication and everything was CID. So that's communication design. Communication design was, I think, split into context and design and communication design. Context and design. Yeah, I think that was it. So one of them was about ethics and morals. I'll start off with that one, perhaps. Okay. So the context design was where you kind of, we were given the task to write an essay about the context and design. An essay on kind of ethics and morals in design and what we need to be focusing on and everything. So yeah, you choose your own topic of what you want to write on. It's about 500 words you need to write. I would say just write about something that you're very interested about, very passionate about, and yeah, try and go deep perhaps. I don't know, it's up to you, you'll see. So context and design, and then communication design CID, we have about 50 pages that we have to complete. So it was, again, intense. That's all I can say, really. It was quite intense, but it was also very, very, very useful. Again, like I just pretty much like every other module, but because like I'm using a lot of the skills that I learned in CID right now with a lot of the things that I do for Swearin, for instance, but like storyboards, product storyboards, demonstrating how each step you would actually need to take to use a product that you've designed, for instance. How would you communicate that most effectively and most simply, like stuff like that, things that you might not consider was ever necessary, but actually the very, very important things. We also learned about quick sketches, like how to do quick sketching. Sometimes just to express an idea, right? You don't want to be like fiddling with all the details, right? You just want to quickly sketch something. So we learned about that. We also learned about more details, perhaps, more kind of geometric shapes and how to draw in perspective. So having the lines, you've got like the lines, the kind of vanishing point and stuff like that, the horizon and whatnot. So you basically, and also like cylinders were quite interesting to me. I found, to draw a cylinder, the first one's a bit like fatter or something. I can't remember. There's something, an interesting point about them. We also learned about presentation skills. That was kind of what it started off with, and just like how to present, and there's certain skills and techniques to kind of overcome anxiety when you're presenting, and a different mentality you need to adopt, where you're thinking, I'm here to express, not to impress, for instance. So, it's a profound statement to make, and it's true. So that was, again, just a few examples for CID as well. Right. I think that's pretty much it, right? Is that it? Let me think. Design, CID. Oh, energy and design. That was another technical one. Energy and design, we learn about we learn about energy and design was actually quite cool in a way. Like, we learn about things that you probably wouldn't have learned before. Quite technical, yeah, very technical. Energy and design was probably one of the most technical modules for product design. We learned about kind of all the different formulas that exist, literally, probably. The one you had ones that were compulsory to understand and be able to use, but then you also had ones that were not compulsory, just so that we had an understanding of. So basically, in energy and design, you design something. So you basically you learn about friction coefficients. So that's to quite a large extent. And also has to reduce friction coefficients with the different shapes of, say, the design, say in a car, for instance. So we learned about how to come up with the friction coefficient if the car is in a certain shape, for instance. Or we also learned about friction again with lubricants. So if you've got like a lubricant between two surfaces, how would you calculate the friction between these two surfaces? So you've got a certain lubricant with a certain coefficient, like an E number, and then you've got a certain kind of area, right? Area, so between the two surfaces, and there's then the formula to kind of calculate what the friction would be between the two. So that was like one of the most, I think, important things. So that's another thing that we learned in energy and design. So that's, again, some examples. Wow, we've learned quite a lot. Okay. That's pretty much what I'm going to talk about in this video. Year 2, a whole new load of stuff. But that would be, if I do talk about that, that'll be in a different video. Enjoy. Good luck. Chill at times. Sometimes, at least. It's tough.